meanwhile, off we go, and we can interrogate you as you go.
Yes, by all means. Yeah, I'll take questions along the way. Yeah. Okay. Thanks so much, Simon. Just a word about why why I asked Simon if I could come down here. As you were saying, I've been interested in configuring large systems for quite a long time, and I've seen there's been a lot of interest recently in PowerShell and PowerShell DSC and configuring Azure Cloud and things like that, and I think that this is something that's fairly relevant to my work, so I wanted to see if there was any connections there. And I guess the second angle from my point of view is that, as Simon said, I come from a very practical background, but more recently, I've been understanding the importance of trying to formalize a lot of these languages and approaches, and I know that there's a lot of experience in that on the PL side down here, and I would like to try and just kind of foster and look at the connections there. So it was a difficult talk for me to, I had a lot of trouble kind of deciding how to approach this and what to actually say, because there's a lot of things that I could talk about and I wasn't entirely sure of the audience here. So I'm going to do two things. It's going to be maybe slightly more broad than the title suggests, because I want to take a little bit of time at the beginning and try and just make sure that we've got a common understanding about what I think the configuration problem is, and to talk about some of the practical problems and the background. And then I don't just want to leave it as a completely broad talk like that. So for the second part, I'll pick one small kind of example. I drill down into a little bit more detail and we'll have a look at what that is. Okay, so let's tackle this first part. Let's talk about a configuration problem. In the past, I used to kind of present this thing from the top down, and I've changed my mind recently. I've started talking about it from the bottom up by just looking at the nuts and bolts and exactly what you get. Exactly what you have if you come to configure a machine. So if we start right at the bottom, if you come to, you've got your PC or whatever and you want to set it up, there's a bunch of different things that you have to set up. A lot of different subsystems, let's call them. And traditionally, if you've been in a kind of a Unixy world, then these things will have been configuration files, like the stuff on the left-hand side. Traditionally, in the Microsoft world, there'll have been some kind of GUI, like that thing over on the right there. And nowadays in the Microsoft world, you get the kind of maybe PowerShell, like the stuff at the bottom right there. One difference to notice there actually is that these things are what I would have called kind of, these things are kind of like data files, whereas your PowerShell stuff is a little bit more like some kind of API that manipulates things. So this is something that will come out quite a bit later on. So that's your subsystems inside a machine. The important point, they're all completely and utterly different. They've got different paradigms, not even different, just different syntax. So there's a bunch of these. So I hadn't configured anything by hand for a long time, and last year I thought, I'm going to do this. I want to set up a 3-tier web application in the cloud by hand from scratch, and so I built this thing. I built it on DigitalOcean, but I could equally well have done it on Azure or something like that. And I just wanted to see kind of what was involved in something simple. And so all these things here, all these little documents are configuration files like there were on the previous slide. And the interesting, they're all different, of course, all different languages. The interesting things are the arrows. What I wanted to do was to track the dependencies. So you're looking at managing the dependencies between these. So all of those arrows represent dependencies between the configuration of these different subsystems. And they're kind of important, the firewall's got to open the right port, the same port that this daemon here is running the service on, otherwise it doesn't work. So dependencies within inside the host there. And you can extend that. If we extend that up now to configuring a cloud application, you get exactly the same kind of thing at the next kind of level up. You've got a bunch of dependencies now between your machines. Your application servers depend on your cache servers and your database servers and so on. So you've got these dependencies. But we've got this second important concept that I'd like to flag, in that you get now lots of machines configured in similar ways. So all those red things are kind of application servers. So they're similar configurations in some way, but they'll have maybe small differences between them. So that's the second kind of important thing. And of course, all this is a problem, is a serious problem in practice. I was chatting to someone from Microsoft last week, actually, on the service side, and this was unprompted, kind of what they told me. You know, so setting this stuff up really is a real problem. And so my area of research, my interests are in building kind of configuration tools and languages and things to make this easier. And so the first 3 points on there are some of the important things I think that came from the previous slides. We're trying to build a tool that is going to make this process easier. So first of all, you need some kind of uniform way of managing all those disparate subsystem configurations that you've got, and it might be a programmable API, or it might be a more common format for specifying those configurations. You need some way of then, once you've got those into a common format, then you need some way of representing and managing and the relationships between them, you know, so that you can say that two things use the same port number, and you can be guaranteed that it will stay like that you don't get a drift between the two. And you need some way of kind of sharing these common configurations with some kind of variation on them, you know, saying, well, I want 20 servers and they're all the same, but, oh, they've got these slight differences, you know, so it's this slight variation on the commonality. And this is kind of where those first three, I guess, are the space of current tools. So the kind of things that I'm interested in then are really taking that up to the next level, you know, to deal with higher level abstractions now, which are exactly the kind of things you need to do in the cloud. You know, if you're building this massive, you know, however many systems they had, 10,000 in the cloud, you don't want to be talking about just how you configure one machine. I want to have higher level abstractions. I want to say, well, this is a cluster of compute servers, and I want another cluster of compute servers that's the same as that. So I want to be configuring things at a higher level of abstraction. And the other thing that I would like to do is to have something that I could at least reason about in some way. So that having built this complicated system, I would like to be able to guarantee that some kind of properties of it. You know, if I have some bits of imperative code that go away and configure two different systems, then it's very, very hard to say anything about the relationships between those systems, or very hard to prove any kind of properties of it. So those kind of things I'm interested in. Okay, so that's the general sort of background problem. And then just before I go into something more specific, I want to try and explain that two different approaches historically to this. And they've tend to have been called imperative and declarative in configuration terms historically. But I just be a little bit kind of careful if you compare those to the same kind of usage of those terms in programming languages, because they tend to mean slightly different things. So the imperative stuff means that you have some kind of, you specify the configuration in terms of actions that you do to something to build the configuration that you want. And traditionally this might have been a bash script like that. Nowadays it might be a PowerShell script. But it's basically an imperative programming language that takes something and turns it into something else. And yeah, the reason this is quite complicated here for doing something fairly simple is that you tend to want to make these the operations in this thing idempotent, because you want to be able to kind of run these things on some system and then run it again in case it failed, and you don't want it. You know, you don't want the same user adding twice to your password file. You only want it in once. So you end up with a lot of this kind of checks in there. And then the other approach is to do things in a much more declarative way. Is rather than giving a set of actions, is just to say, this is what we want. You know, we want a user called Elmo, and they'd better be present, and they'd better be in that group. And some kind of deployment system then has to sort things out to match that.
You'd like to be true of the final configuration.
Yes.
Okay.
Yes.
And then,
yeah. So a little bit more detail just about how each of those two things happens in practice. and some of the issues. So the imperative approach is pretty straightforward, because in the early days, before people had any tools, they just they did it manually, and then the next stage was to start writing scripts that replicated those manual actions to automate it. So you want to build something like that figure over there, and you've got a set of stages that add things to it. But when you're building big things, this is really has a lot of problems. You know, it's very hard to take a complicated set of steps like that and to prove that anything about the final state of the system. And indeed, if you look at lots of configurations, people don't even, it's not even written down anywhere what the final state ought to be. You know, the final state is defined by whatever happens after we've run all this stuff, you know. And so it's very hard to kind of prove anything at all about the configuration that you've got.
In the old days, it'd be a single admin administering machine.
Yeah, absolutely. Absolutely. This is exactly what I want to talk about. Yeah, yeah. And I mean, even in terms of the steps, I guess that's my third point here in terms of these steps here. I mean, they're done, you know, there's no indication of what could be parallelized or whatever in the steps. But the stuff about multiple users, I'll come back to. Yeah.
Is it also to do with exceptions, or if things fails, like if you, you know,
yes.
you can't add an arm, then you can't add the hand, but
that's
the legs
right.
You can still add.
Yes.
So if you had a bit more information about dependencies, whereas if it's in a sequential thing,
yeah.
You know, who knows?
Yeah.
Just stops or something.
Yeah, okay, and absolutely, and that's related actually to this third point here, that this assumes that you kind of know where you started from. So if it breaks halfway through and you have to restart it, or it wasn't quite like you thought it was, then the thing's going to break anyway. But this is still popular, and this is what happens. And in fact, you know, this is what a lot of stuff is configured like this, whether it's under Unix or like PowerShell in Windows now. This is the way that a lot of things are built. But we'll come back to that. So the alternative is what's been called the declarative approach. And actually, I really like the Windows term of kind of desired state rather than declarative, because declarative has some kind of PL connotations that are not necessarily appropriate. So what we're doing here is we're specifying the desired, you know, the final state of the system. And so it's completely independent of how you deploy it. You're just saying, this is what we want. And we've got some kind of specification of what the thing should look like. So having deployed it, we can then compare what we've got with what we wanted, and we can tell whether it's the same or not. But obviously, there's a big, it doesn't tell you anything about how to do it, right? So you do need to compute a workflow between what you've got at the moment and the final state. And I'm just going to kind of mark this as out of scope, but I'm very happy to talk about it if anybody's interested, because what we've done on this is to use automated planning, and we can take these two states and we can plan sensible deployment workflows and things like that. Yeah, and they're guaranteed to meet certain properties throughout the workflow transition.
Would it be fair to say that rather than giving a sort of single, complete, consistent description of the desired state, you just write down a set of properties that it should have? There should be this user, you know, this computer should be connected to that. And these independent properties might or might not be mutually consistent. Because you might in one place say A should be connected to B, and somewhere else you might say A should not be connected to B, and that might not be very obvious. Is that
We'll
right?
get there. Yeah, yes, 2 slides away.
Okay, fine.
Yeah.
So, but then
3
you've
slides
got
away.
just to write down properties rather than. There's 2 ways to write down the desired state. You could just write down exactly what it is, or you could write down properties that it has.
Can I address that particular question on one slide later on? When I come to consolve, remind me if I forget how to do it. Okay, so just to round off that first section, just something about the history of where these things come from. The red stuff is stuff that I've been involved with, and this middle line thread is kind of what I would say is the production, is what's kind of happened in production. So way back here, I was building kind of internal tools for kind of managing university systems, and those grew into things for managing things like the European data grid, where we're talking about maybe tens of thousands of machines or something like that. And then at some point, I kind of stopped getting up in the night to fix disks and started doing kind of research instead. So those red things are research things over there. But a lot of these involved into what's probably the most common declarative style configuration language at the moment, which is Puppet in the middle. And a lot of the ideas from Puppet have been kind of picked up, and they're now reappearing in Microsoft's DSC at the end there. PowerShell in kind of in brackets, because PowerShell's not really a kind of declarative configuration language, it's a sort of scripting language. So one thing that I wanted to flag here is that there's this strand at the bottom. Quite a lot of these things here became extremely complicated to use. And I think there's been a reaction against that towards much simpler and more imperative tools because of the complexity. And I mean, I kind of think this is a big mistake, because these kind of tools have a lot of problems for building big systems, as we talked about a moment ago. But, you know, a lot of people have been moving that way because of the complexity, you know, and I think this is motivating something that I'm trying to do to simplify these kind of languages and tools here, which I think are unnecessarily complicated.
They advertise being simple because they're only describing the desired state and not the root.
Yes, but
I thought that simplicity was the goal. Right?
But the semantics of those languages are extremely complicated. If we talk about, I'll talk about inheritance later on, for example. You write something and it can be extremely difficult to work out what's going on. Okay, so just a little bit about the architecture. The architecture's not changed very much, actually. It was quite funny. I was looking into the Azure automation stuff and I found this diagram on the right, and it's pretty much identical to this one on the left here in terms of the process. So there's some kind of description of the state you want. Something munges that around and it produces a document in XML, which is a desired state of these of your target machines, and then something deploys those desired states onto the target machines. But the crux for me is the difference in in these sources here and this stuff and how this is constructed. What tends to happen in this case, for example, if you look at a PowerShell DSC configuration, these configuration bits here are kind of pretty declarative. They give you the desired state, but the way that these are constructed, they're constructed using pretty imperative kind of PowerShell code. So that somewhere in the middle here, you do have a declarative description, but it's pretty hard to reason about where that came from, because it's been constructed out by kind of arbitrary complex code. So what I'm interested in is, can we, rather than constructing these things using some kind of arbitrary programming language, which a system administrator has to do, not a programmer, you know, can we build some kind of higher level thing that allows a system administrator to say what they want in a fairly declarative way and have it translated into this? And so for me, this is the kind of crux at the moment. That was part one. So that's my kind of overview and a background of where I think the configuration thing is at the moment. So what I'd like to do now is I'd like to take one small kind of problem, and I'd like to drill down a little bit harder into that one thing for the second part. So this was where the original title of the talk came from. So we've got these configuration languages, and they're not programming languages. What we're describing is, we're not describing a computation, we're describing a configuration. And you might ask, well, why? No, you go right back to the Lego man with the JSON. You know, why is there more to it than that? If we want to give a description of the desired state, why don't we just write down a bit of JSON that describes what it is that we want? Well, when you're putting these things together, and this comes back to the point that, you were asking a moment ago about when these things are built by multiple, you know, they're not built by one person. You don't configure 10,000 machines with one person. There's lots of different people involved. And what the different people are doing, they're not configuring one machine each. You know, they've got overlapping concerns about what they're dealing with. Somebody's configuring the networking. Somebody's configuring the DNS service and things like that. And they want to kind of talk about configuring their concern without being too worried about how it kind of clashes or overlaps with other people. So you've got different people managing these overlapping concerns, and you want to compose them together in a sensible way. So this is the this is the sub-problem that I'm going to look at for the example in the second part. Here's my domain. And I'll justify using something very simple in a moment rather than a real one. But you can kind of see what's going on here. You know, if you were to look at a bunch of computers in your cloud, you know, they might look like this, you know. But, well, maybe there's a reason why these two guys have both got red hats. You know, this is not kind of random. There's a reason why they need to be like that. You know, and these two are identical, you know. And there are these kind of relationships between different aspects of them. So I'm going to use that as a domain for talking about some of these problems. And I'll show you some real problems later on, but you won't want to do it using those. So here's a very common, this is a very common operation, but it's been given lots of different kind of names. People tend to call it inheritance in configuration languages like Puppet, which is very common, but that's very confusing. OO people tend to think it means class inheritance or type inheritance or something like that, but it isn't. It's a form of instance inheritance. And I've actually been calling it kind of specialization, which is just to get away from this rather misleading term. And this is really, really useful, because what people want to do is they want to take some generic description of something and then they want to specialize it. And they want to just sort of pick and choose the specializations that they want. So you might have some generic Red Hat machine here, and you might have some description of what it takes to make something run Apache, and you might have some generic description of what it takes to make something run WordPress, and you just want to kind of stick them all together and get something that works in the end. And I don't really want to care about what's inside these things here. I just want to pick and choose these kind of functionalities and compose them together. So what else is there to say about that? Oh yeah, I've just been using this symbol here for the composition. This is not a standard symbol at all, but this is something that I've been using in the languages that I've been working with. Oh yeah, there's a bit of a red flag here. There's a lot of confusion about what we mean by ordering in configuration languages. So the ordering that's implied on here is not any kind of temporal or deployment ordering. It doesn't say we have to build the systems in that particular way. Somebody's just saying this statement here. That doesn't kind of mean that you have to build the system in that particular way. So this is a very typical problem, and if we go right back to SmartFrog was quite an early language, and this was a language that was developed at HP. It was never very widely used outside of there, but actually it was really nice because it was the most, it was the clearest language that I'd seen for doing this kind of thing. We actually we built a denotational semantics for this, and we managed to do this kind of fairly easily, you know, because the language was so nice and clean. So this is what we saw a moment ago, this thing about composing these bits together. So here you've got, remember these are instances, not classes. So this says here our configuration has got two servers in it here. And if you have a look at this S2, that thing here is something that inherits, extends this S1. But it's got this slight change to it. It's got the web servers running, is not running in it. And then this S1 here is something which is a machine, which has got some DNS name, and it's got a web server in it, and the web server that's in it is an instance of one of these, and so on. So you can see we're kind of describing an instance of a configuration. And that's... So this kind of process is very complicated. It's very common. Puppet does this as well, but they nowadays they actually. Sorry, yeah, go.
Sorry,
PC2 extends machine. I was just wondering if it was significant that the service was called S1, as was the machine at the top.
It doesn't look like it, does it? I don't think so, no. Actually, Puppet had something very similar to this in it, but like the semantics was like so horrible that they just recommend nobody uses it anymore because we spent rather a long time trying to do a semantics of this, and we've been doing an operational semantics of this, but like we haven't really managed to capture a lot of it. It's truly horrible. Okay, but like, so what happens is you get conflicts now. Oh, I have to apologize for the sexism of this, which I didn't realize until I put it together. There is actually an International Association of Women in Fire and Emergency Services, and they had a web page which does make that statement at the top, but they seem to have taken it away. But it was there. So my point here is that, like, now your problem is that if you have overlapping concerns, then your order of these compositions now starts to matter. Do apologize because this, as well as being sexist, it's not very clear. This thing here has got short hair on it, you know, so the idea here is that, well, this short hair is now conflicting with this long hair, and when you have a sequence of instance inheritances like that, then the last one wins. So you're going to get different results for the two different things. And this, now you're going to tell me, oh, like, this is really naive. Why are you drawing these silly pictures and things like this? This really, really, really is what happens. These are what cause you real trouble in configuration. Here's the documentation.
Undetected conflicts, that is,
yeah, absolutely.
because of some happenstance of order.
Sure, yeah. You just get the last one, and someone looks at that and they go, well, which one of these do I put first? You know?
And are you saying that you prefer to be told, look, there's a conflict between these two requirements?
Or we prefer to solve it in some way, which we'll talk about later on. But there's the, you go right back to that first slide that I had, which said all these subsystems have got different ways of specifying these. That's the documentation for the Apache web server configuration. And have a look at the rules about the ordering of those sections. This is exactly what we were talking about on the last slide here, you know. And somebody comes along, and so you come along and you want to add this bit to this configuration, and there's 6 pages of Apache directives there, and there's these instructions about how you should put things in the right place. You know, you're not going to do this unless you're an expert in this, right? Or you're going to make mistakes, okay? And this principle is important. That's one example of it. Here it is again. In a Microsoft context, you're doing exactly the same thing with group policies, you know. So they inherit from different places, and like, well, which group policy do I stick this value in here? You know, it's going to override that one, or it's going to be more priority than that one. So you've got the same kind of thing happening. And last year I had a student doing, so I'm interested in the usability of these things. How do we make this more usable? And last year I had a student working on this, and we surveyed 300 system administrators, or maybe 300 people. Maybe over 200 of those were professional working system administrators. And we had a whole series of artificial examples of bits of configuration like this, and we asked them kind of what they thought about them, whether they thought they were obvious, what that would mean, and so on. And if you take this one here, this is doing something very similar. This music box here is doing a kind of a double inheritance to get the value, so it will get a different value from the box and a different value from the player. And we asked people what they thought the final value would be. And okay, so you got a big split. Most of them thought this one, which is probably what a programming language person would think, given the order of these inheritances here. But of the remainder, 25, a quarter of them thought it should be the other thing. And the remaining quarter I either didn't know or thought it would be an error or were confused by it, you know? And so these are working system administrators, and this is a really simple example. Compare this to the real examples we had a moment ago. No, but what's misleading is that it was part of a two things to say. One is that it was there were a bunch of other examples before that were simpler, that they were given some answers to, and the other one was we were also kind of interested in exploring this thing about what the system administrator's intuition was, because they were used to seeing lots of different languages like these ones we had at the beginning. So when we're building a new language, we were thinking, well, we kind of, if we're going to do something new, we should try to match their intuition, So we were looking for kind of intuition as well. So it's quite understandable that people got different answers, yes. But what was quite interesting was their confidence levels, right? Most people were quite happy. Oh, yes, it works like this. Okay, that's how it should work. But of course, no, if this was a new subsystem they were configuring, they just kind of guessing, and the ones I've seen before work like this must work the same, I'm confident, And this, so...
No, they were guessing because you hadn't told them the semantics, and yet they were extremely confident.
Yes,
in their guesses.
Yes,
right.
Yes. Yeah. Okay, and then there was a bunch of kind of really interesting comments. Of course, I like the last one. The first one is perhaps the most interesting one to me. So what we're trying to do here is, it kind of looks like programming languages, but I wanted to step back and I wanted to say, what is it that we're really trying to do? What do people really want to say? And what kind of language would allow them to do it easily? So those are the kind of things that I'm interested in. And what we really want to do is we really want to do some kind of composition. This is what, if you think about the Apache and the WordPress one a moment ago, this is really, really what we want to do. We want to say, well, I've got one of those things and I've got one of those things, and I kind of want one that's both. So this is what I mean by composition. And this is a very common operation. And at the moment, people do all sorts of ad hoc things, or they use inheritance and they get it wrong because the ordering's wrong, and so on. So I'm just going to talk a little bit about some things that we've looked at with that. So what you really want is you want a commutative operation, because the person who's going to put together these things has no idea what order they should go in. I mean, there's no, why should I, how should I know the details of all the insides of all these things to know the right order, So the user at the moment is forced to make a decision. But they don't have the information that they need to do. And you need some kind of composition operator where the operators, are, the authors of these components are deciding what order they're going. And this problem resolving kind of these conflicts, it's not something you can do with the existing information you've got, because if you look at it, there's often lots of different reasons why people will write down a value for something, Somebody might well say, look, really, it has to be this value. And if anybody else says anything different, that's a problem, and they're wrong, But quite often, there's some slot that someone has to put a number in that they just don't care about at all, Well, I don't mind what's in here, but it's forcing me to put something in, so we'll put 0 in and leave it, And then there's all sorts of other kind of reasons why people might want to put those in. And those reasons are not captured you've no way of capturing those in existing languages. So one thing that we looked at was a couple of years ago was a Microsoft-sponsored PhD project with Andy Gordon. I had a student called John Hewson who built a configuration language based on constraints. And this is exactly what Simon was asking about a moment ago. So rather than specifying everything and saying we want all these bits here, you would just give some kind of constraint properties that you wanted. And you could say very expressive things like this. And this worked, this was good. the thing is, it's kind of unusable for most day-to-day configuration. Because it's like incredibly difficult to specify things that are sufficiently tightly specified that they say what you want, but are loose enough to give you the variability. Really hard to understand. You know, example I was using at the time, you know, was that suddenly you find that the the departmental mail server is running on your laptop because you forgot to tell the configuration system that this really wasn't. So you have to be really careful. And so this was very good at doing kind of very specific jobs like this, but it didn't really kind of solve the usability issues of the previous one. Example. So I've been playing with a very simple configuration language, which I just called L3, and this is really just an experimental test bed of mine where I've been playing with a few ideas and planning to use it for some usability studies and things like that. And so one of the things I was playing with was an attempt to get this halfway house between those rigid compositional orders that people have to specify and this completely open sort of constraint specification that we saw a moment ago. And so what we can do here is, okay, so we can specify resource values, like we've got this thing called A, which has a structure in it, which has got a color that's red, and B is another one that's got a color that's blue. And when we give a value, we can also tag it with an arbitrary tag. And then when we come to compose these things together, we can give some kind of constraint on the preferences of those tags, so that when this A compose B now is actually a kind of a union of values. It's both red and blue, and different people have different preferences for those. So if we now evaluate that in a context where we prefer what Alice is saying to what Bob says, then we're going to get a different value from evaluating it in this context here. Hi, thank you.
So this is all treating the components of the states of the configuration all totally independently.
Yes, yes.
So presumably inside the heads of system administrators, they have a huge pile of invariants that say any working configuration, if this field is this, then this one must be that.
Yeah.
Is any of that captured?
Well, if you go back to that console language, that would be captured completely, because you would essentially give the loosest possible thing. You would actually specify the negatives. You know, if you go back to
So you could, but
yeah,
have you?
So you absolutely could with that. You would say certain things like, I just want this service running on 10 machines, and I don't care which 10 machines it is as long as they're different machines.
So if you have an Apache server and a cache server, for them to play nicely together,
yep,
presumably their configurations have to, in some sense, match up.
Yes.
That's a generic property that could be written down
yes,
not too many times.
yes.
Is that knowledge captured in any of these?
Yes.
systems?
Can I show it on the next slide? Yeah. Okay, so this was an attempt to find a kind of a halfway house between the very specific things and the loose things. So statements like these things at the bottom you can say using that kind of language there. And actually two special tags are kind of top and a bottom one. You know, there's a final one that says really, really it has to be this value, and there's a bottom one that says, well, if nobody else has given a value to this one will do, but don't. Can. And you can now use that and put that together. If we take the example that we had before, you can now put those kind of things together.
So for you, the
the things you're composing are nested records of values.
Nested records of values,
Okay,
yes.
and then you're just concerned with how you combine these nested
I'm concerned with how you combine them,
where they potentially conflict.
That's right, yes. Yeah. And so you've got, oh dear, we've got the terrible sexism again. I think this says that your female has to wear lipstick, but if we ignore that, this is saying here, this is my generic figure here, and this is just default stuff. So you can override this if you've got a better idea. This one here says the whole lot of this is kind of final. If they're going to be a fire person, then they've got to have short hair, and they've got to have a hat on, and they've got to have a uniform on. And this one here in the middle says, well, if they're female, kind of like, they've got to have a female face, so they've got to look female, and, you know, the hair's probably kind of long, but if someone wants to do something better, you can do. And then if you combine those things here using these things here, you get kind of what you'd expect, you know, and these things here commuting properly. And so that's what's happening. Oh, and I guess the point there was that it's interesting in practice. These kind of final and default actually cater for a lot of the situations that you meet in practice.
Is it a final default just apply to single values or the whole?
No, it'll inherit into the whole block, but I'll talk about that again in a moment. And the original operator that we had, this specialization operator, which is like an instance inheritance, you can now express this in terms of the composition operator. You know, if you want everything in Y to take precedence over everything in X, then you can just add a tag to these and the corresponding constraint, so you can express the specialization.
Lots of tags, because the stuff in X might already be tagged.
Yes, lots of tags, yes, potentially, yes.
So everything has lots of tags.
Yes. Oh, sets of tags. Yes, I'm sorry. Sets of tags. Yes.
Okay.
Yeah.
Is there any distinction between one of these records being tagged and each of the individual fields within it being tagged? So you say X tagged with blah, and then all the fields of X tagged with blah. Is that different or the same?
That is the same in the current semantics. Yes.
Thanks.
So. So this is just something that I'm playing with at the moment. This is very easy for people to understand, and it seems that it gives the right kind of composition semantics in lots of cases. But it's not, even though this is a really simple compared with a lot of real configuration languages. There are, you know, there are a lot of decisions to make. If you is it confusing for people? And this question here really, well, what you were asking there, how should they propagate? You know, if we tag a whole structure, do they attach to all of the members recursively? Is it sufficient? You know, and if not, what kinds of problems are they not handling? And also, like, this is going to seem pretty weird to most working system administrators if you kind of give it to them. You know, and you're trying to evaluate it. How do you know whether it's kind of sensible or whether it's just because they're, or whether they? How do you know whether they genuinely think it's a bad idea or they're just not familiar with it, and so on? So these are the kind of things that I'm kind of looking at, and I think, yes, you see this. Maybe I won't go into this into a lot of detail, you know, but the semantics here are kind of interesting, you know. You've got an A and a B there, and because this kind of constraint's attached to this block and this constraint's attached to this block, you can't actually have the same value for C dot port because it conflicts, but they could choose, it could have different ones. But, you know, that we would kind of hope that these two things, you maybe expect these two things to be the same, you know. And so they're kind of, there are kind of variations on the semantics which have different kind of usability issues, and so this is just one example of something kind of looking at the moment. Yeah. So just what am I trying to do? I think there's a big problem with complexity. I mean, I was looking at the Azure things recently, and there are many, many different languages and paradigms stuck together in very complicated ways. And I think that that's putting people off in practice, and it's a big source of practical errors. I think that there's a lot of different people involved in building configurations, and you need to explicitly address this separation of concerns and the composition of them. And you need some way of specifying these kind of your higher level intent in a more declarative way. I think if you take something which is basically a desired state description, and then you expect people to use quite complicated program code to generate that, then in some ways you're kind of losing the value of the declarative specification that you've got. And unlike programming languages, these things are not formalized. They're extremely ad hoc. I've already talked about that the problems with the formal semantics for Puppet is very, very difficult and very kind of weird. So I think that there's, I guess one of my aims here is try to say that there are kind of interesting, language formalization problems in these kind of areas. That's something that I would like to look at. And oh yeah, that was we were looking at these things. I was talking. This came from a student project a couple of years ago that was trying to last year that was trying to just look at generating these pictures automatically from the specifications, so you could see how they work together. But it gives you a good idea of, we're trying to be able to talk about whole things. I'm trying to be able to talk about a team as one kind of unit, and I want another team like that, which is exactly the kind of things that you're trying to do in a big cloud configuration. And you want to be able to, manipulate these things in a whole, as a whole. I'm conscious I didn't answer your question, did I? I thought it was Kelly. Tell me.
So for a global configuration to be working, presumably there are some generic constraints between the pieces that have to hold.
Oh yes, yeah.
So the
Yes. Yes, I kind of did, but I didn't mention it. Where's it gone? Yeah, so it's rather in this thing here. If you had a server and a client, and they have to share the port, then what's happening is you're modeling the service as one unit, and you're modeling these things as references to the single.
But here that's the same. They have to have the same value for a single field.
Yeah.
Are there not constraints that involve lots of fields simultaneously?
Yes, yes, there are, and I think what you're verging into now is this question about how much you want that to be computed automatically and how much you don't. So right at one end you've got this very open, loose constraint thing where you can say to sysadmin, you don't put any fixed numbers in there. All you do is you put in the rules, And at the other end, the very specific end, you would say, well, you put some rules in and you put real numbers in and you lose flexibility, And you have to pick a point, I think, on that spectrum, because the one end is not flexible enough, but the very flexible end is not usable enough because the sysadmins just don't, it's too easy to make mistakes, Well, we put all these rules in, and it deployed this really stupid configuration. Where did this come from? And I don't know how this is going to work. It's too complicated. So what I'm interested in is finding this kind of sweet spot on that spectrum where people have enough flexibility to say the kinds of things that they want, but not a completely automated system that will be difficult to specify and will generate unexpected stuff.
You can imagine adding assertions on this, right? Our just logical statements of the values and check at the end if they hold, rather than trying to solve them and pick values that satisfy them.
Right, well, that's what we do in programming languages typically. Say program, it does something, right? And here, separately, we state some properties that it should have. It's allegedly a square root function. One of the properties it should have is that if you square the output, it should be the same as the input. That's a fairly complete specification. But you might say something like, the length of the output list should be the same as the length of the input list. That's what it's referring to as an assertion.
Right.
Then you might hope to verify dynamically or statically that those assertions actually hold.
Yes.
Right.
So this, I really like that you brought that up because one of the things that I'm kind of interested in here is right between these communities of the programming language community and the practical kind of sysadmin community. And if you look at a lot of the existing configuration languages have the ability to put some kind of assertions on there about what these values should be. Don't get used, not time, right? and something breaks and someone goes like, oh dear, you know, we could have put an assertion in to stop that, let's add it, you know, and they add one insertion to stop that. And then the kind of, you know, a week later it kind of pops out at some other phrase. And, you know, I think the way in which these configurations are built in the real world are very, very agile, you know. Look, oh, you know, this web server's overloaded. I need another one now, you know. I haven't got time to kind of go and design this like I would design a bit of software and you know, write these assertions. I put it.
You would, over time, accumulate a collection of assertions that you would like to be
Yes.
true of the Edinburgh Informatics IT
Yes.
system. You know, we don't have more than 3 mail servers running on any.
Yes.
They just accumulate these, and
Yes.
they stay pretty stable. You
Yes.
keep changing your configuration, but you hope that it always
Oh,
satisfies
absolutely,
these assertions.
absolutely, yes.
And then when you find something breaks, you sort of add one to it.
Yes,
So
absolutely.
With a bit of luck, it would be
Yes.
they'd be
Yes.
equally agile.
You would absolutely hope that to happen. I mean, what happens at the moment is those assertions are only really made at a kind of macro level because your languages don't allow you to talk about services at that high level. They don't have the abstraction to handle the high level. So once you've got the abstraction to handle the high level, then certainly you would expect those kind of things to go in. Yeah.
We look at language for build systems because they seem to have lots of similar problems. So Microsoft has this language called MS Build, which is some XML. It's supposed to be declarative, but it's not, and it has all these hooks in it, and now nobody understands how it works anymore. And it's caused huge problems.
Sounds like a good definition of the state.
And there was this effort to try to replace it with a declarative language that has a semantics, but
Yeah, what happened to it? I don't know.
smart, you know? I think it was, you know, still not a solved problem.
Roger?
Since you didn't mention it, so I think it might be relevant. In automotive, so when you spec your car using this website, so I think so there's quite a branch of constraint satisfaction and sort of configuration, so where they trying to figure out if you
absolutely, yeah.
okay, so you were
Yeah. I mean, there's a whole bunch of work about putting cars together or washing machines with the right kind of bits. Yes.
they seem to always focus on actually solving why something is not possible. For example, if you spec inconsistent thing, but this never to mention the language aspect.
Yes. Yeah. I mean, I think that all that stuff is very relevant. Going back a few slides to those more constraint-based console kind of solutions, you know. Whereas here, I'm more kind of focused on the kind of usability and finding a spot between them. Yeah. Sorry.
Yeah, picking up on Andre's point, it seems like there is a flip side to this where, I mean, you can imagine situations where determining what the configuration data is very easy, but that configuration data is controlling very complex interacting processes.
All right. Okay. Yeah.
And it's that determines the correctness of the configuration. You know, you have to basically reason about the semantics of those.
Yeah.
I'm thinking of things like internet routing protocols.
Yes.
Right. The configuration data is fairly straightforward.
Yeah.
But
I think that there's another level. So this takes you from some kind of, abstract description of the parameters you want in your target machine to the actual parameters that you want in the target machine. Right. And then there's another stage to the problem, which I think you're talking about, is like, well, what's the behavior of the final system? Does the behavior of the final system meet some requirements? Yes. And I think that's another stage to the problem. Absolutely. Right. Yeah. Sorry. Yeah.
So I've got an observation which I think is maybe independent of what you've been saying in your talk, which is that we have this notion that a service should run on a particular port, say 123. That should be in the specification for the service, and the client should know that the service is running on port 123.
Right.
But it seems to me this is a little bit like saying a function should put a variable at address 123, and whatever's using the function should know to go and look at address 123 to get the result of the function.
Yeah.
Really, this should just be abstracted away. The service should run a port, and there should be some way of communicating through a variable.
I think this is exactly what
kind of Peter was saying a minute ago. Right, so if you go back to that console thing, you could exactly do that, because you could just say these two values should be the same. I don't care what they are.
Oh, sure, yeah. So
Right.
a solution would just be picking an arbitrary
number. Yeah, but that's not usable in practice. Like the sysadmins hate that, you know. Wait a minute, I'm going to ship this.
What was it?
I have no idea what is going to happen when I push this out. And someone's going to come and tell me, you know, all my servers have gone down because it's got 37 in here. Where did it come from? This is your fault.
But that's more a social problem, isn't it? I mean, programmers don't complain that
Yeah.
a variable went to a particular address rather than another one. That's more a social problem than a technical problem.
Yes, but I guess to some extent, yes, but the domain that we're talking about here is to support that social interaction, and that's why, and that's motivating a lot of what's going on. In the same sense that you know, we could use much more maybe powerful programming paradigms or something in this, but we don't want to because they get it wrong. So it's kind of what are simple ways of allowing people to say just what they want to say without giving them so much rope that they hang themselves, you know? Because you see it the other thing, you could say, oh, well, we could put all these powerful programming constructs in here. Sure, fine. But then you're going to get a load of sysadmins who use them not very well, and hundreds of them are put together, and your system is running on that, and we don't want this. So it is, you know, a social issue as well.
You also worry that you might have, you need to say, and don't use the same port, 1, 2, 3, for these two different things, which independently chose a number. So you somehow want to say, choose a unique one, right? But then it has to be unique, not across the whole system, but just for that machine. So sort of specifying the scope of the uniqueness might be tricky.
Yeah.
And then the other thing I was wondering is whether your sysadmin, when the system's running, they say, oh, I'd like to snoop on port something, because then I can see the traffic going by. But which port does the system choose? So being able to answer that question,
all
you'd
those
have
issues.
You'd
All
have
of
to
those issues,
be able to find out easily if it was chosen on. And that's not true of, well, it's kind of true when you're in the debugger, right? You'd like to know, what address did you put that console at? But you hope you don't have to do that too often.
I suppose a way to put the prevalence of these defaults is that distributed systems like these, especially across many services, don't have a calling convention. There is no uniform set of choices like we have in machine code that are well respected.
And so I think this is a big problem because there's no sort of uniform set of underlying primitives that you could implement either imperative or declarative style languages on.
Regardless of whether you configure your entire system using this, someone's laptop doesn't. And their calling conventions matter to your system. So you need to have these defaults. You need to have those recipes we've always used port 48 for this because we used it in the 80s, and sometimes that matters.
Well, maybe we genuinely reduce the lowest common denominator regardless. So.
Yeah, I mean, this is related as well to the number of people that are involved in writing these. You know, if you have people collaborating on a program, I mean, sure, they have to meet at the interfaces, you know, and they're dealing with kind of separated chunks. You don't have lots of kind of overlapping concerns, whereas in the kind of configuration problem, you get lots of things that overlap all the time. You know, I've got to have enough disk space on this machine to hold that and that, so who's responsible for the disk space? And if I put this version on here, it's going to need more disk space, and, you know.
Lots of undocumented assumptions are being made by the services these are configuring. So you've got to change agilely for that too.
Yeah.
It's just past 11, so I think we should probably wrap up. I should say that Paul, you're around till 1:30.
Yeah.
Right. So hang around. If you'd like to have a chat with Paul at some point later today, just hang around afterwards. We'll construct a little program from sort of on the fly right now. And Tom, you're going to lunch with him, right?
Yes, that's right.
Excellent. Okay. So thank you very much, Paul.
Okay. Thanks.